Okay, today we're talking about Pythagorean Theorem and some different ways that we can use it to classify triangles. So for any right triangle, it turns out that a squared plus b squared equals c squared. And that's what's known as the Pythagorean Theorem. Now it's important when we look at this that we notice that a and b are known as the legs of the triangle. They're the shorter of the two sides. Remember, we know the largest side will always be opposite the largest angle. And in a right triangle, the largest side is always the side opposite the right angle. So C here in Pythagorean theorem represents the hypotenuse. Hypotenuse. So when we write the Pythagorean theorem, we want to make sure that we put the hypotenuse, or largest side squared, equal to the sum of the two smaller sides squared. Okay, that's what the Pythagorean theorem tells us. The Pythagorean theorem is used when we need to find a missing side of a right triangle. See that right triangle mark there in the corner? It has to be a right triangle for a Pythagorean theorem to be true. And when it's a right triangle, it's super powerful. If we know any two sides, we can always find the third side with Pythagorean theorem. So let's see how that's going to work. It says find the value of x, make sure your answers are in simplest radical form. So no decimal approximations here. We're going to break it down by hand if it needs breaking down. Okay, so I notice that the side opposite the right angle, that's my hypotenuse. So I'm going to set it up that the hypotenuse squared equals the sum of the two side squareds. The two sides are x that we don't know and the 12 that we do know. Okay, so and now we want to solve for x. Well, I know that 12 squared, that's a perfect square, so that's going to be 144. I have that memorized. And 13 squared is 169. And that's about as high as I go on the perfect squares that I have memorized. But you can use your calculator to help. I'm going to subtract 144 from both sides. That goes to 0. So I know that x squared equals 169 minus 144 is 25. Now, we've got x squared equals 25, and we want to solve for x. So how do we undo a square? With a square root. That's right. Okay, those are inverse operations. They undo each other. Now, something super important happens mathematically when you take a square root. You pick up the plus or minus options. This is a degree 2 equation, meaning 2 is the highest exponent on the variable. That means that we expect to have two solutions, and the positive option is one solution and the negative option is the other solution. Now, this will happen every time we take a square root, but often we don't need one or both of those answers. So for each time you take a square root and you pick up the plus or minus option, you need to come back to the problem you're working on and see which of those, if either, we're interested in our situation. Well, we're getting the sides of a triangle, and so when we're talking about the length of a side, the lengths of our sides are always going to be positive. So here we're going to throw out the negative option, and we just say x is the square root of 25, which we know is 5. So my answer here is x equals 5. So Ms. Weaver, why all this concern about remembering that we get the plus and minus option when we take the square of a square root? It's because as you advance in your mathematical education and in your career, you're going to find lots of applications where you do need that negative option. And mathematically, it happens every time we take a square root. So we're going to show it every time, even though for these problems that we're working today, where we're just getting side lengths, we know we're really only interested in the positive options for today. Okay, let's take a look at our next problem. Okay, so it is a right triangle, so we're okay to use our Pythagorean theorem. Now remember, we said the Pythagorean theorem says that a squared plus b squared equals c squared, where c is the hypotenuse. All of these are just variables, and so we can switch them out with any other variable. The important thing is that the two sides that get squared and added together are the legs, or shortest sides, and that the hypotenuse is the c value that gets squared. So when we look at this triangle, it is a right triangle, so we're okay to use Pythagorean theorem. My two shortest sides, again, are x, so I'm going to square that, and 7, so I'm going to square that. And together, the sum of those squares will equal the hypotenuse, which is my largest side opposite my right angle. So that's 9 squared. We just want to make sure we drop them in the correct place. So I've got x squared plus 7 squared is 49. 9 squared is 81. And now I want to solve for x. So it's just algebra from here on out. I'm going to subtract 49 from both sides. That goes to 0. So I know x squared equals 81 minus 49. That's going to be 2. When I borrow from the 7 to make that 11, that'll be 2. And then 3. So x squared equals 32. Now, we want x, not x squared. So how do we undo a square? With the square root. And when we take the square root, something super important happens. We pick up the plus or minus option. Even though we know today for our applications, the lengths of the sides of our triangle will never be negative, so we'll throw out that option. And x is just the square root of 32. But what is the square root of 32? That's not a perfect square. So now I need to simplify under my radical. I'm going to do a prime factorization tree. So I start with my smallest possible prime, which is 2. And 2 goes into 32 16 times. You can just divide that on your calculator or do it in your head. Some of you who are really good at math, you'll be able to just think of this as division upside down. 2 goes into 3 1 time, and that leaves me 12. 2 goes into 12 6 times. So you can try it that way in your head if you want to work on building your number skills. That's still even, so 2 goes into it again 8 times. 2 goes into 8 4 times. 2 goes into 4 2 times. As soon as the number on the right is prime, I know that I'm done. I look down the left side and across the bottom. Now this is a square root, which means we're taking the second root. You don't have to write the 2 there on the radical when it's the second root, because that is the most common. And so by default, it's square root if no number is written. But the thing about that number, it lets us know how many of each number we have to pull it out from under the radical. So here we need 2 of every factor. I have 2 2's here. I have another 2 2's here. And this 2 is all by itself, which means x equals, I get to pull 1 2 out for the first group of 2's, another 2 out for the second group of 2's, and I still have under the radical that 1 2 right there that didn't have a partner. So that 2 will stay under the radical. These numbers that get pulled out front get multiplied together. So we multiply the numbers in front of the radical together. 2 times 2 is 4. And then we would multiply the numbers under the radical together if there was more than 1. It's just the 2, so it'll stay 4 on the square root of 2. Final answer. So x equals 4 on the square root of 2. All right, let's try another one. Okay, this time it's the hypotenuse that we're looking for. It is a right triangle, so I'm okay to use Pythagorean Theorem. Plugging into those positions. Sometimes I like to write the formula every time, especially while we're learning it. It helps me learn it. I want the 2 legs, which are the 2 sides that meet to form the right angle. I want those squared and added together, so 3 squared plus 4 squared. And they're going to equal the largest side, which is always the hypotenuse, squared. So that's x squared this time. 3 squared is 9. 4 squared is 16. Okay, equals x squared. 9 and 16 makes 25, so 25 is x squared. We undo a square with a square root and something super important happens. We pick up the plus or minus option, even though today for the sides of the triangles we know we're not interested in negative options. So we just get that x is the positive square root of 25, which is just 5. Okay, so our hypotenuse here was 5 units long. Okay, and one more just for good measure. Okay, it is a right triangle. Remember, it has to be a right triangle to use Pythagorean Theorem. Okay, so I'm ready to solve for my missing side. If we know 2 sides of a right triangle, we can find the third side with Pythagorean Theorem. Okay, so a squared plus b squared equals c squared. So let's plug our numbers in the correct place. My 2 legs, the 2 sides that meet to form that right angle, are 10, so 10 squared plus 4 squared. And that's going to equal my hypotenuse squared. Remember, the hypotenuse is always the largest number, even though we don't know what it is here, okay? We do know that it's going to be bigger than 10 because it's always the largest side of the triangle. So let's try that. 10 squared is 100, plus 4 squared is 16, equals x squared. So 116 equals x squared. We know that we undo a square with a square root, So I'm going to take the square root of both sides, and when I do, something super important happens. We pick up the plus or minus option. Even though we know for this application where we just want the side lengths of a triangle, we're going to throw out the negative options. We're only interested in positive options here. But what is the square root of 116? It's not a perfect square, so let's do a prime factorization tree, starting with the smallest possible prime and see how it breaks down. 2 goes into 11 5 times with 1 left over. That makes 16. 2 goes into 16 8 times. Or if you just want to do it in the calculator, 116 divided by 2 is 58. 2 goes into 58 29 times. Now 29 is prime, so I'm done. Looking down the left side and across the bottom, I've got a pair of 2s and then a 29 without a partner. So you have to, like, one way that I've heard to memorize this is that you've got to have a date to go out. So the 2s have a pair, so they get to come out. The 29 is lonely, has to stay in the house, thinking of the radical as the house. Kind of a sad way to remember it, but it's funny, and I'm able to remember it that way. Okay, so final answer here, x equals 2 on the square root of 29. Now, if you're not sure that that's bigger than 10, you can check yourself. Put it in your calculator. 2 times the square root of 29. They're bumped up next to each other, so that means they're multiplied together, and you'll get a decimal approximation that is, in fact, bigger than 10. All right, let's try one other thing I wanted to point out here is that there are things called Pythagorean triples that are worth your time to memorize. It says a Pythagorean triple is a set of positive integers a, b, and c that fit the rule a squared plus b squared equals c squared. Okay, so what we're saying about a Pythagorean triple is that they're all positive integers. Okay, they're positive integers. Because a lot of times, you saw in our problems that we worked, we don't get integers as our answer. We get something under a radical, which we have to simplify. It's a complicated looking answer. But sometimes it turns out to be perfect integers, and those are known as triples. So 3, 4, 5 is a Pythagorean triple, 5, 12, 13 is a Pythagorean triple, 7, 24, 25 is a Pythagorean triple, and 8, 15, and 17 are Pythagorean triples. And there's an infinite number of these, but what we're saying is that if you had a right triangle with legs 3 and 4, the hypotenuse would be 5. Okay? If you had a right triangle with sides 5 and 12 for the legs, the hypotenuse is 13. Okay? If you had a right triangle with a hypotenuse 25 and a leg 7, the other side would be 24. If we had a right triangle with a hypotenuse of 17 and a leg of 15, the other side would be 8. And so if you memorize at least those first 2 Pythagorean triples, there are going to be many problems that you can just look at and tell us what the remaining side is. For example, that 3, 4, 5 triple, let's go back and look at some of the problems we've already worked. If we look at number 3, we had 2 sides that were 3 and 4. We could have automatically known that the hypotenuse, the largest side, would be 5 because it's a Pythagorean triple, a 3, 4, 5 triangle. Okay, let's go back and look. If you look at our 5, 12, 13 triple, we did a problem that had that as well. If you take a look at the first problem we did, number 1, we had 2 sides that were 12 and 13. Because the hypotenuse is the biggest side, the 13, we knew that that other side was going to be 5 because it's a 5, 12, 13 triangle. Now, often as math teachers, we will build Pythagorean triples into our problems so that you can quickly solve them by recognizing it as a triple instead of having to go through the work to solve the entire problem when Pythagorean theorem is not the focus of our problem or when we want you to have an easier answer, kind of a nice whole number, easier to work with. Now, a word of caution about using Pythagorean triples. Be sure the number for the largest side, of the triple is in the hypotenuse's position. And let me show you what I mean. Okay, so remember we said that the largest angle has to be opposite the largest side? And because triangles sum to 180, you can't have another angle as big as 90 or bigger than 90 because there's only 90 degrees left to split between the other two angles of a triangle. So if we know we have a right angle, we know it's the biggest angle, and so the largest side has to be opposite of it. So if I see a triangle where we've got 3 as a leg and 5 as a hypotenuse, I'm like, okay, oh, that's 3 and 5. There's a 3, 4, 5 triple, and 5 is in the hypotenuse position. So yes, I can use my triple, and I know that remaining side is 4. But if we have a right triangle with legs 3 and 5, you might be tempted to say, oh, that's a 3, 4, 5 triangle, but wah, wah. 5 is not in the hypotenuse's position. So the remaining side that we don't know does not equal 4 because that whatever it does equal, it's got to be bigger than 5. And in fact, if we used Pythagorean theorem to solve for it real quickly, 3 squared plus 5 squared would equal x squared. So that'd be 9 plus 25 equals x squared. So that would be 34 equals x squared. We undo a square with a square root, which means we pick up the plus or minus option, even though we're going to throw out the negative option because we only want positive sides of our triangle. That breaks down to 2 times 17, which are both prime. So there's no pairs to pull out, meaning it doesn't simplify. So x there would equal the square root of 34. It would not equal 4. It does equal the square root of 34. Which is between 5 and 6. The square root of 36 is 6, so that's just smaller than 6. Bigger than 5, but smaller than 6. Okay, questions about that? If you have them, write them down, and we can answer them as soon as we start class tomorrow. Okay, so what about Pythagorean theorem converses? We have more to do today. So let's take a look at Pythagorean theorem converses. Now, you can use the Pythagorean theorem to determine if a triangle can be classified as acute, right, or obtuse. We said if you already know that it's right, then we can use it to solve for a missing side. What if we don't know if it's right or not? Well, we can check and see by Pythagorean theorem whether or not it is. So remember, when you're given 3 sides of a triangle, we need to first check to see if the 3 sides form a triangle. If they don't form a triangle, then it can't be a right triangle, acute triangle, or obtuse triangle because it's not even a triangle, right? So we need to first make sure that it's a triangle. We discussed this several units ago, so I have a recall here to remind you. Remember that the sum of any 2 sides must be greater than the third side to form a triangle. Now, if one of the 2 sides is the largest side, it's automatically going to be greater than the third side. So the one situation we really have to look for and check is that the sum of the 2 shortest sides is greater than the longest side. Okay, is it greater than the longest side? So we'll want to check that first. Once we've made sure that it is in fact a triangle, then there's 3 situations we're looking for. We want to see how c squared compares to a squared plus b squared. So I have a big blank here because we're not sure how c squared is going to compare to a squared plus b squared. If it turns out that c squared is less than a squared plus b squared, then the triangle is acute. Now that's easy for me to remember because acute is little or small angles less than 90. And so when c squared is less than a squared plus b squared, it's going to be the little triangle, the acute triangle. But what's important when you're remembering that comparison is a memory cue to help you remember it. Make sure you remember that we've got c squared first. We're comparing how the hypotenuse squared compares to a squared plus b squared. If it turns out that c squared equals a squared plus b squared, then it's a right triangle. Right? That's what we called the Pythagorean theorem, that a squared plus b squared equals c squared. Well, if you just flip which side the expressions are on, c squared equals a squared plus b squared, that's still our Pythagorean theorem. It's only true for right triangles, Okay, so we know it's a right triangle if c squared equals a squared plus b squared. So what about if c squared is greater than a squared plus b squared? Can you guess then? Well, I think of greater than as the big ones. That's going to be our obtuse triangles. Then the triangle is obtuse. if c squared is greater than a squared plus b squared. So let's put those notes into practice. Let's try a few combinations of sides and see whether or not they form a triangle, and if they are, if we can classify that triangle as acute, right, or obtuse. So our first set of numbers is 3, 7, and 9. We first want to see if they make a triangle. So we're going to check, are the two smallest sides, the sum of the two smallest sides, greater than the third side? 3 plus 7 is 10. Is 10 greater than 9? It is. Therefore, and remember our three balls stacked in a triangle is the therefore symbol. Therefore, it is a triangle. Okay, it is a triangle. Okay, so once we know it's a triangle, we can proceed to step 2. And that's deciding how c squared compares to a squared plus b squared. Now, this is not a mathematical symbol. It's kind of like back in your kindergarten and first grade worksheets when you would have a big blank where you had to fill in the symbol. That's what we have to decide. That's how does c squared compare to a squared plus b squared? And we don't know yet. Remember, c squared is always going to represent the largest side. So how does 9 squared compare to the sum of the two shortest sides? So that's going to be 3 squared plus 7 squared. How does that compare? I don't know. Let's check. 9 squared is 81. 3 squared is 9. 7 squared is 49. 9 plus 49 is 58. How does 81 compare to 58? 81 is greater than 58. Therefore, oh, and I said 58. 9. That's right. Okay, sorry, just double checking myself. I wanted to be sure. So that's going to be an obtuse triangle. Since c squared was greater than a squared plus b squared, that's going to be an obtuse triangle. 4, 11, and 16. Remember, we first need to decide, do these sides form a triangle? So do the sum of the smallest two sides, is it greater than the largest side? So 4 plus 11 is 15. Is 15 greater than 16? Wah, wah. 15 is not greater than 16. 15 is not greater than 16. Therefore, this is not a triangle. If it's not a triangle, we just stop there. It certainly can't be an acute, right, or obtuse triangle because it's not even a triangle. Okay, that's why we check. Saves us some time. Okay, let's try our next one. Are our two smallest sides, 17 plus 17, is the sum of the two smallest sides greater than the third side? Remember, we're checking to see that if these two sides were at either end of the largest side, would they be able to meet each other to form a triangle? And so in order to be able to touch each other when they're attached to the ends of the largest side, together they have to be longer than that largest side. So is 34 greater than 22? You betcha it is. Therefore, this is a triangle. So we're ready to proceed to step 2, which is checking to see, how does c squared compare to a squared plus b squared? We don't know, so I'm going to put a little blank there for us to fill in the sign for how it compares. We don't know. So 22 is my largest side, so it's going to be c. So it's 22 squared. How does that compare to 17 squared plus 17 squared? Now, we're using our calculators to square these numbers, so you can go ahead and put it all that together in one at one time, meaning you can do 17 squared plus 17 squared, and you'll get 578. Or if you wanted to, you could put it in separately. 17 squared is 289 plus 289. And either way, you would get 578. So, okay, so since we are using the calculator anyway, you might as well put that side in there together. That equals 578. 22 squared is 484. And you can do this on your phone calculator too, because your phone calculator, if you turn it sideways, it can do square and square root, all of that stuff. Or you can use the Desmos calculator that's linked on our webpage. Okay, so how does 484 compare to 578? Well, 484 is less than. So if c squared is less than a squared plus b squared, what does that mean? Therefore, It's an acute triangle. I think those acute little triangle, those are our little triangles. So when the c squared is less than the sum of the other two side squareds, it's going to be an acute triangle. Okay, and one more to try. 18, 24, and 30. What do you think? What do you think? Is it even a triangle? Do the two shortest sides added together, are they greater than the third side, than the largest side? Is the sum of the two smallest sides greater than the largest side? Well, 18 plus 24 is 42. 42 is greater than 30. Therefore, it is a triangle. And we're ready to move to step 2, which is to decide what kind of triangle it is. We want to classify it. So how does c squared compare to a squared plus b squared? I really do like the fill in the blocks. Okay, so c is my largest side, so that's going to be 30 squared. A squared and b squared, it doesn't matter which one I put where, but they have to be the two smallest sides. So 18 squared plus 24 squared. Okay, so how are they going to compare? Well, 30 squared is 900. And how does that compare to 18 squared plus 24 squared? If you do that at one time in your calculator, 18 squared plus 24 squared is 900. So how do they compare? They're equal. C squared equals a squared plus b squared. So what does that mean? Therefore, what kind of a triangle is it? It's a right triangle. That's our Pythagorean theorem, that a squared plus b squared equals c squared. That's only true for right triangles. So this must be a right triangle. Awesome. Okay, so now for a little word problems. It says draw a picture for each word problem and solve. A television screen size is reported by its length on its diagonal. Did you know that? Like if you go in to buy an 85-inch TV, who even has a TV that big? Not me. But what that is that's the length on the diagonal. Okay, so that's what, when they tell you the TV screen size, that's what they're telling you is the diagonal length. So if a television screen measures 30 centimeters wide and 22 centimeters high, and we know it's built at a right angle, right? Nobody has a slanted TV screen. We know it's built at a right angle. So we do have to know it's a right angle before we can use Pythagorean theorem. But now they want to know, what is the diagonal measure of the screen? What screen size would that be reported as? And since we do know that it's built perpendicular, with the two sides perpendicular, forming a square edge, then we can go ahead and use Pythagorean theorem to solve for it. So we said Pythagorean theorem says a squared plus b squared equals c squared. So our two shortest sides have got to be the legs, and these are the two sides that meet to form the right angle. So we know our answer is going to be bigger than 30. So 22 squared plus 30 squared, because the largest angle always has to be opposite the largest side. So x must be the biggest side. And I'm going to put x in there. Okay, if we do that in the calculator in one step, 22 squared plus 30 squared, and if you need help with your calculator, just ask in class and we can help you with it. That's going to equal 1,384. That equals x squared. We don't want x squared, we want x. We know we undo a square with a square root, okay, and that picks up the plus or minus option. We don't want a negative length on our TV. Lengths of sides need to be positive, so we'll throw out the negative. The square root of 1384. Now, earlier our answers said in simplest radical form, but with word problems, you never go to the store and say, I would like 5 root 2 feet of lumber, or I need a screen that's 7 root 35 yards long, okay? When we're doing real world problems, we always want decimal approximations for our final answer. And so here, we're only going to come and get the decimal approximation in our final step. So now we're ready to go to the calculators for that part. The square root of 1384 is approximately 37.202 centimeters. Okay, when it doesn't tell you how many units to round to, I always go to 3 decimal places, just because on the AP calculus exam, they want you to go to 3 decimal places. So that's just what I do unless the problem tells me otherwise. So this would be about a 37 centimeter TV. That's not as meaningful to us here in the US. We usually use inches for our TV screen size, but if you lived in London or somewhere else that uses the metric system, that would make great sense to you. If you're from India, that probably makes great sense to you. You have a good idea of what that size is. Okay. All right, let's try another word problem. A ship leaves port and sails 12 kilometers west and then 19 kilometers north. How far is the ship from the port? Okay, so if we're going to do a navigation problem, we like to start with our little crossbars, and we think of that as our northeast, southwest. Okay. And this says we're going to travel west 12 kilometers. That means we're going exactly west, or straight west, as straight as Miss Weaver can draw. And that's 12 kilometers. Okay, so we go that far. So this was our port that the ship was starting at. And we went 12 kilometers west. Okay, when you get to the end of that length, make your compass mark again for your northeast, southwest. Now it says, then the ship went 19 kilometers north. That means exactly north. So we're going exactly north 19 kilometers. Okay, so this is where my ship ended up. It started at the port. It went 12 kilometers west, 19 kilometers north, and now here it is out in the water. How far is the ship from port? How far is the ship from port? Okay, remember it started here at the port. Okay, so this is what we want to know. And what I do know is not only is this a triangle, but I know that when we came from directly west and went directly north, those meet to form a right angle. Those are perpendicular to each other. North and any of the other cardinal directions are perpendicular to each other. Just like our Cartesian plane, those are all right angles. Okay, we know those are all right angles. Whew. So those are all right angles. Okay, if these are right angles, that makes a right triangle, so we can use Pythagorean Theorem. Okay, our new a squared plus b squared equals c squared. Can you put your sides in the correct places? The hypotenuse across from the right angle, that's our x, so I'll put that in c's position. My two legs, the two sides that meet to form the right angle, are 12 squared and 19 squared. Well, they were not, we're going to square those. When I put that in my calculator, 12 squared plus 19 squared, I get 505 equals x squared. We don't want x squared, we want a plain x, so what are we going to do? We undo a square with square root, which picks up the plus or minus option. When we're talking about distance, distance is always positive, and so we're going to throw out the negative option. When I put that in my calculator for a decimal approximation, I get that x is approximately 22.472 kilometers. Okay. And let's try one more word problem because we always need to practice word problems. Sherry went to a level field to fly a kite. Okay, so I like to draw pictures as I go. I wish I had a green here for the grass for the field. Maybe I'll do brown because maybe it's a field in the winter. So it's a level field, meaning that it's flat. She let out all 650 feet of the string of her kite and tied it to a stake. Okay, so we're going to put a stake in the ground that she could attach it to. Okay, so she's going to attach the string of her kite to that stake, and it says she let out all 650 feet of her string. So at the top of that is her kite there, floating in the wind. Okay, it says, then she walked out on the field until she was directly under the kite. So let's put her directly under the kite. Which was 600 feet from the stake. So when she was directly under the kite, she was 600 feet from the stake. Okay. How high is the kite from the ground? So what they would like to know is how high the kite is from the ground. Well, height is always measured perpendicular to the ground. So from the kite, if we go straight down perpendicular to the ground, that's going to be our height. The height. Height is always measured perpendicular to the ground, so I do know that's a right triangle. Okay, I do know that's a right angle, which forms a right triangle. So if I look at that triangle, I know two sides of a right triangle, so I should be able to find the third side using Pythagorean theorem. So my a squared plus b squared equals c squared. You don't have to write out the a squared plus b squared equals c squared part every time, but while we're new at this, it kind of helps me make sure I put things in the right position. My largest side is across from my right angle. That's my 650. So that goes in the hypotenuse's position as c. Okay, my two legs, one of them is 600. The other one, I don't know. I'll call it h for the height, okay? Now, I need to solve for my height. So 600 squared is 360,000. We don't know h squared. 650 squared is also a really big number, 422,000, and we're just using our calculators for that, 500. Okay, when I subtract 360,000 from both sides, that cancels, goes to 0. That leaves me h squared equals 422,500 minus 360,000 is going to be 62,500. Now that's what h squared is. We don't want h. We want h squared. We don't want h squared. We want h. So how do we undo a square? With a square root, which picks up the plus or minus option. When we're talking about height above the ground, that's a positive number, so I'll throw out the negative option. That means that our height, and we're going to get an approximate here. Oh, actually, this one turned out to be a perfect square. Who knew? So not a wavy equal sign. The wavy equal sign means approximate. It lets my people that see my work know that I know that this is no longer an exact answer, that I rounded it. So here, if it is an exact answer, I don't want to leave it a wavy sign. I'm going to tell them, no, this turned out to be exactly 250. And remember, we need units for word problems, so that's 250 feet. You can use the feet symbol, which is the single apostrophe, or you can write out the word feet. So the height ended up being 250 feet. Okay, if you've got questions, let your teacher know at the beginning of class. We hope this was helpful for you.